Record this as well. Alright, so simplification. So if I have a to the power of 10 divided by a to the power of 5, subtract the powers when dividing. So when I subtract, I'll use a different example. A to the power of 6, the answer is a to the power of 4. Can also be written like this: a to the power of 10 divided by a to the power of 6 is equal to a to the power of 4. Okay. Right, what if I had a to the power of 10 divided by a to the power of 3 times a to the power of 4? What happens there? First of all, I have to figure out the bottom bit. So it will become a to the power of 7. Now I subtract a to the power of 3. Okay? First of all, I deal with the numbers. 6 divided by 2. 3. Now I deal with the letters. A4. Okay, start with the number 10 divided by 5. Alright, the a to the power of 3 divided by a to the power of 2. A to the power of 1, or a. Now the b. 4 minus 2, 2. Okay, and see if we can find. Just keep looking up. This is an actual question in the exercise. So again, start with the number 5. Now the a's, that's to the power of 1. A to the power of 5, and b to the power of 1. Or you don't have to write the 1. Just keep looking up, and I'll give you some exercises to do in a minute. What about right, this is a good one. So first of all, we deal with the signs. We have minus and a plus. Minus and a plus gives you minus. Look up, down there.
Minus 4.
3. Now it becomes x to the power of 0. 7 minus 7, 0. Look up. X to the power of 0. X to the power of anything. So if I have a to the power of 0, 1. B to the power of 0, 1. If I have a million to the power of 0, 1. If I have a house to the power of 0, 1. X to the power of 0 is 1. But what is 1 times minus 3? Minus 3. So some people say that these cancel each other. But does it really cancel each other? No, it becomes x to the power of 0, it becomes 1. 1 times minus 3 is still minus 3. Alright, a bigger one. 64 over 8. X to the 4, x to the 3.
8x1.
Y to the 5, y to the 2.
8x.
Z, you can write Z like that with a dash, so you don't mix it up with a 2. Alright, so it should be, yeah, Philip, 8.
8
X.
x 1.
y3, isn't it?
No, but what about this thing, sir? 4 and 3?
x1, yeah, sorry, x1, y3, z,
2.
z2. It's a good idea to write z's like that,
Why is that, sir?
just so you don't mistake them as a 2. Right, and there's the harder one. So if I have x squared, let me see, minus 2x over x minus 2. Now if you pay attention and look up, first of all, you'll notice you've done these sums before. On top, x squared minus 2x. You need to factorize that. What can you bring outside? Look up. So you can bring x outside. And it looks like that. Yeah? I'll write it over here. X squared minus 2x. What did we do? We brought the x outside. X times x is x squared. X times minus 2 is minus 2x. See? So I've written this here. I've replaced it. Alright, what will cancel? What are you left with? The answer is equal to x. X is left behind. Alright, another example. What is this sum on top an example of? I have an x squared and an egg and a number. Difference of? The top one is 2 squares. So x squared minus 4. Remember the squares? That's x by x and 2 by 2. So the answer is x minus 2 times x plus 2. So I'm going to replace this with x minus 2 times x plus 2. Now what can I cancel? That. What am I left behind with? X plus 2. Okay, I'm just going to stop at that point.